Hey everybody, Noah here with Learn Meta-Analysis, and in this video I want to show you guys how to actually extract data from a study for conventional meta-analysis. So we're going to be using actually it's one of my papers, but it's publicly available on the internet, and we're going to use it because I know there's some things I reported and there's some things I probably didn't report because it's an old paper, but we're going to use this one as an example so you can see what it is like to actually extract data for conventional meta-analysis. Now, one of the things that I want to point out here is with this study we are going to be looking at, there are only two groups. So we don't actually, and well, on top of that, so there's only two groups, which helps reduce our issues with statistical independence. And then the second piece is we only actually have one outcome measure that's going to be of interest to us. So I'll talk about why that's important as we start coding. So I'll just go to the top here so you can see what paper this is. This is the influence of pedagogical agent on learners' cognitive load. And so the citation was Schrader 2017. So that's where I'm going to start off. I always start off with my citation for the article. So I'm just going to put Schrader 2017. So I do also record the year in a separate column, and the reason I do this is because I like to be able to say we found studies from this year to this year, and then I like to be able to create a line graph of it so that I can visually see how the trends have gone in the field over time. And just having this column here is a very easy way to make that happen in your analysis phase. So publication type, this is a journal article, so I'm just going to select journal article. Next, I have virtual character's appearance, and I want to know about the age first. So if we go here, most of these questions, let me scroll back here. So you can see most of these questions are probably going to be addressed in the methods section, right? That's one thing that's quite important is this is all going to be in the methods, which means we don't need to read the full paper right this instant to get the information that we want for this particular coding form. It may not be the same for your coding form. For your coding form, you may need to read the whole paper and read it in depth. In fact, anytime you're extracting data, I really encourage you to read the whole paper and understand the whole paper so that you don't miss anything or misinterpret anything. But for the purposes of this video, we're just going to skim through different parts, and I have not looked at this paper in years, so hopefully I'll be able to find them quickly and this won't be a super long video. But I know from working in agents for the last decade that this is the type of information that should be reported in the methods if it's reported. So let's see, we're going to go down to the methods section first, and we are going to see what the agent's age looks like. So we can see our agent right here in figure 2, and this looks like an adult. So we're going to go back to our coding form, and we are going to choose, funny, I just realized I typed in age instead of adult on that other video. Oh, that's really funny. I'm glad it's so easy to change that here. So let's go ahead and change that. It's going to say you have a lot of other drop downs. Do you want to apply it to all? We're going to apply it to all. So that's kind of funny. Just make sure I didn't mess that up. Yeah, okay, so we have an adult. Under form, we could see this was human-like, right? That looks like a computerized human. So we're just going to click on human-like. And under gender, we can see that this is a male virtual character, so we are going to click male. Okay, now under role. Now this is a little bit more complex, and this is where we're actually going to have to read about what the character did. So typically where I would look in an agent paper is under computer-based materials and design, and it would tell you generally what's happening. So in this case, this tells you how we built the character, and it was basically a voiceover PowerPoint. And it also says the virtual human remains stationary. So those are both interesting and important to us. So let's keep that in mind. But for now, we had just voice over PowerPoint. And if you recall, when we created this coding form, I just put role A and B because I didn't want to actually type out the 6 different roles that are relevant here because I didn't want to take up extra time in the video. We'll pretend like role A was simply a lecturer, just an information source, and we'll click that. Gestures. Now, this is why I said you wanted to keep in mind if the agent moved. So here it says it remains stationary, okay? And it doesn't say anything about gestures at all. But since it says it remains stationary, I am going to make the assumption that that meant there are no gestures. And for the purpose of this, I'm just going to click example 2. So very simple, right? We're basically taking descriptive information from the study and we are translating it over here to our coding form. Now, one thing that I do want to mention that I hadn't done so far is that I save all of these files to my computer. I save all of the PDFs that I'm going to use. And I will also do things like highlight in there when I extract data. So if whoops, sorry, I clicked on figure 2 on accident. So if I wanted to highlight this, virtual human remains stationary, I would go ahead and highlight that in my saved copy of the PDF. And that way in the future, when I come back and I'm trying to figure out where I got information from, I don't have to search the entire document from scratch, right? I'll have, maybe 15 or 20 things highlighted in here, and I can much more quickly navigate to that information. And you may be thinking, oh, when would I ever go back and look? Trust me, you're going to end up going back and looking, right? Because you want to make sure that your information is correct. So you're probably going to end up double checking studies, or maybe during iterator reliability, somebody will ask a question and they'll be like, oh, that's not what I coded. Let's take a look back at the original study and figure out what was actually going on. And so we can talk about it and make a decision. So I like to highlight what I actually extracted, like where I extracted the data from, for every single point of data that I extract from my coding form. So I'm not going to do that here for the sake of this example, but just know that that's something that I do, and it's something that I recommend. Okay, so where are we at on our coding form? Okay, we now need our effect size information. So you can see we have the experimental group, mean, standard deviation, and sample size. That is for our group that worked with the character. And then we have the control group that didn't work with the character. So in this paper, I know, because I wrote it, that the means and standard deviations for the learning outcomes are in this table, in table 1, right? And so this is very easy for us to translate. So we can see our control groups. Now, this is something I want to point out, okay, that is like a really easy way to mess up. In this paper, I report control group first and then experimental group. In my coding form, I have experimental group first and then control group. So make sure you have the information in the proper boxes. Otherwise, you're going to have wrong effect sizes. Okay, and you definitely don't want that in your meta-analysis. So let's go ahead and extract this data. So we have 15.64 for the control group's mean. Under standard deviation, we have 4.51. And I did not report the sample size in this table, so we are going to go back and get that sample size out of the methods instead. So for now, we're just going to jump ahead to the experimental group, which was 15.61. Whoops. There we go. And we need the standard deviation, which was 5.53. Okay, so now let's go hunt down those sample sizes. And we know, as researchers, that that should probably be in the participants section, right? Okay, so we can see here, they're randomly assigned either the control group, which had 33, or the experimental group, which had 36. So we're just going to take that information and place it into our coding form. So a lot of people freak out because they're like, oh, extracting data is so hard, etc. It can be. So what I gave you was like the easiest possible example, right? So we didn't have to deal with any ANCOVAs. We didn't have to deal with what happens if they report standard error instead of reporting standard deviation. We didn't have any of those types of situations where we had to do some computations to be able to actually get the data that we want for this. And we also didn't have a case where they reported the information, but not in a way that we could actually use it. So something that you may run into is when they report an ANCOVA and they'll report the overall F statistic, but they don't report the mean standard deviations. And so that becomes a situation where we have data, but it's not actually really useful for us because it's got that covariate in there. And if they didn't give us the means and standard deviations, that means we're making estimates based on an effect size, which we can estimate from that F statistic. That is a whole nother set of videos, right, on how to do that type of thing. There's great resources online to help you with those types of conversions as well. But my point being that this is the simplest possible example, and you can see this doesn't have to be complicated, right? If researchers have good reporting, then the meta-analyst job becomes very, very easy for data extraction. So the only other thing that I'm going to point out here is recall that we did not have any other variables of interest to us in this analysis, right? So let's say, hypothetically speaking, that we actually had more than one measure of learning, right? Because if you recall, our example that we're working through is focused on learning. Well, what happens if they have a retention test and a transfer test? Okay, that's problematic for us, right? Because we need to remember that principle of statistical independence. So we can't include both of those things in our conventional meta-analysis. It's going to cause a problem. So we have to make a choice. Choice number one is that we pick one. We use either the transfer scores or the retention scores. This is the approach that I prefer. And you should have a written policy that actually gets written into your report of why you chose to do that and what you chose to do. So in most cases, in educational fields that I'm aware of, we're mostly interested in transfer scores, which is applying that new knowledge to some new situation, rather than retention scores, which is just simply remembering in the similar context. So if this study had both retention scores and transfer scores, personally, for my for my interests, I would probably be reporting only the transfer scores. Now, another decision that you could make is you could make the decision to find a weighted mean and pooled standard deviation of those two scores and use that. So I don't like that, and the reason I don't like that is because A, it confounds the data, in my opinion, because they're not the same types of test, and B, if you have variables in your coding form about the type of measure used, it's going to create problems because you no longer have a good comparison. So as an example, you can say that your retention test, let's say that's multiple choice, but the transfer test was actually a performance assessment. So if you're coding what type of test it was, how do you code that if you combine those two tests? You really can't, right? You can't in a way that's going to be meaningful. You'll have some variable there that's like mixed test types, but when you go to do your moderator analysis, that's going to be kind of useless information. It's not going to actually tell you anything particularly meaningful. So the other possible challenge you could run into here is if there's two experimental groups and one control group. Now, you probably think that it's okay to compare each of those experimental groups to the control group, but it's not. And the reason would be that the control group is going to be in the analysis twice, and you can't have that because of the principle of statistical independence. So what you need to do is the same thing that we would have to do with the outcomes. We either need to pick one group, and this is the approach that I personally take. I usually will pick one group that has the least confounding variables. And what I mean by that is when there's two experimental groups in my field, typically it means there's the control group plus one variable and then the experimental group plus another variable, so that we end up having two variables that are different compared to the control group in one condition and only one variable that's different in one experimental group. So I tend to choose that of just using one group scores. The other option is to combine those two group scores using weighted means and pooled standard deviations. But again, you start to run into those problems in your moderator analyses because you no longer have a clean comparison if they were different types of groups. So let's say one learned with a child virtual character and one learned with an adult virtual character. When you go to code that, you would have to be saying mixed character types. That's not really particularly helpful, right? It doesn't tell us anything meaningful in regards to that outcome. So I prefer to just pick one group if I'm doing a conventional meta-analysis, and I have a written policy that I report in my manuscript as to what I did and why. So, all right, so I realized I forgot something, so I'm sorry that this is just getting tagged on, but something that I wanted to mention is I always have a description of the comparison here, so that way I know what's actually being compared. So if we remember this study, it was comparing an agent versus no agent condition. So I'm sorry I forgot that. In the next video, we'll talk about coding 3-level meta-analysis and how that's different. So thank you guys, and I look forward to talking to you in the next video.